So let's do an example using Doppler. And in this example, you're driving at 55 miles an hour towards a fire truck that's doing 80 miles an hour. And the siren is at 2,000 hertz. And so you're going together or going towards each other. You stop and let the fire truck go by, and then afterwards you start up at 55 miles an hour again. So we want to know the frequency for each of the situations where you're moving towards each other. You're stopped and the fire truck is moving towards you. You are stopped and the fire truck is moving away. And then the last when you and the fire truck are moving away from each other. And we're going to assume the temperature is 20 degrees Celsius. So we'll write down what we have given. And our velocity of the source is equal to 80 miles per hour. And that works out to be about 35.763 meters per second. The velocity of you, the observer, is 55 miles per hour, and that's about 24.587 meters per second. The frequency is 2,000 hertz, and the temperature is equal to 20 degrees Celsius. Well, the first thing that we want to do is calculate our velocity of sound. And we'll use the formula that we had at the beginning of this chapter. 331 meters per second plus 0.6 meters per second degree Celsius times our temperature. We'll fill that in. And that gives us 343 meters per second. And the formula that we want to use from the last video, f prime, which is the same as the Doppler frequency, is equal to the frequency of the source times the quantity, velocity of sound, plus or minus the velocity of the observer over velocity of sound minus plus velocity of the source. So let's take a look at each of our examples. So in the first example, first part that they're asking, we're both moving away from each other. So remember, we need to use the top signs. So we use the plus and the minus. And we'll have frequency of Doppler is equal to frequency times velocity of sound plus velocity of the observer over velocity of sound minus velocity of source. Okay, got that all written in. And if you do that calculation, you'll get about 2,393 hertz. Or we can write that as 2.393 kilohertz. So that's part A. For part B, well, the difference here is that you're still moving towards each other, so we're going to use the positive on the top and the negative on the bottom, like we did in the last section. But now the velocity of the observer, or you, is equal to 0 meters per second because you've stopped. So our frequency for the Doppler is equal to frequency times V sound plus V observer over V sound minus V source. That's 2,000 hertz times 343 meters per second plus 0 meters per second over 343 meters per second minus 35.763 meters per second. And our calculation on that is 2,233 hertz, or approximately 2.233 kilohertz. So our Doppler shift reduced by over 100 hertz. Now, for part C, you're still stopped, so V observer is still equal to 0 meters per second, but now this time the truck has passed you, so it's moving away from you, which means we have to flip the signs in the equation. So we have frequency of Doppler is equal to frequency V sound minus V observer over V sound plus V source. And that's going to be 2,000 hertz, 343 meters per second minus 0 meters per second over 343 meters per second plus that would be 35.763 meters per second. And if we calculate that out, we get 1,811 hertz, or 1.811 kilohertz. And now last part D. Now you've resumed back to 55 miles an hour and you're moving away from each other. So our frequency, Doppler frequency, is going to be frequency V sound minus V observer over V sound plus V source. And the result of that is 1,681 hertz, or 1.681 kilohertz. So you notice that when you're moving together, it's the highest frequency. Frequency drops once you stop and the truck's moving towards you. And you would expect these, because you're moving towards each other, to be above 2,000. And this is going to be less than 2,000 when you're moving away from each other. So you're moving away from each other. Your stop, though, you can see that that's down from the 2,000, and then when you're both moving away, that's the lowest frequency. I like this problem because it shows all the different ways to use Doppler.